Hey grade 9s, the most powerful thing about functions, in my personal opinion, is that they have a formula or an equation. Why do I think it's so cool? Well, you can draw a line and you can boil it down to an equation with just numbers and letters. And then someone else on the other end of the world can just take that equation and they can draw exactly the same line. Okay, maybe I'm the only one getting excited about this, but I think it's pretty cool. Anyway, all functions have some kind of a general formula and they can be represented by equations. And straight lines are no different. The general formula for a straight line is y is equal to mx plus c. Now, once in a blue moon, you are going to find that there's a teacher who's teaching y is equal to mx plus q, not y is equal to mx plus c. If your teacher is doing this, I don't want you to worry about it. Just know that the q and the c represent exactly the same thing, okay? I'll be using c. In this video, we are going to be talking about all the features of a straight line. I'll take you on a whole tour of it. And by features, I mean, is the line sloping gently or is it sloping steeply? Is it lying in one direction or in the other direction? Where is it sitting on the Cartesian plane? And I'll also just be going through the formula for a straight line and showing you exactly what each symbol in the y is equal to mx plus c equation represents. Okay, let's get going. Let's get started on the features of a straight line. So every straight line that you can draw on the Cartesian plane will have a place where it's touching the x-axis and where it's touching the y-axis. Do you see that? So it's this spot over here and this spot over here. So we can say over here that this spot where it's crossing the x-axis is called our x-intercept. So our x-intercept, we would say, is -4. And our y-intercept is where it crosses the y-axis. So over here we would say our y-intercept is 4. Happiness. So that can happen with any line. You can have a situation where you have a line going through here like that. Then the x-intercept would be 4 and the y-intercept would be 2. Now, so that's y and x-intercepts, and they're gonna just be featuring all the time. Then you must realize that we can have lines each line has a slope. Okay, what do I mean by slope? By slope I mean how flat or how steep it is. So I can have a line going like this. Imagine it's straight, okay? I can have a line like that. That's pretty steep, right? If I had a little car going up here, that would be a pretty steep hill for it to climb. So we say that's a steep slope, but we don't really talk about slope as much as we talk about gradient. Okay, but slope and gradient are the same thing. So that line has a really steep gradient. Now I can also have a line with a really flat gradient. It looks like this. Just imagine that it's straight. Okay. So that would be really a much flatter gradient. You can have even flatter. So a gradient can be flat or steep. A gradient can also be negative or positive. What do I mean by that? I'm going to get into that a little bit more in the gradient lesson, but for now, it's just enough to understand that I can have a gradient that slants like that, and I can have a gradient that slants like that. Now, when a gradient goes like this, then we say it's a positive gradient because it's lying in that direction. And when it goes like that, we say it's a negative gradient because it's lying in that direction. That's pretty important to remember and to learn. So now I've explained these features to you, but the cool thing is that these features can actually be seen in the formula of a straight line. Well, not the x-intercept directly, but at least the y-intercept. Let's quickly look at what that looks like. So if we've got y is equal to mx plus c, that is the formula of a straight line. you are going to see that there are actually only 2 positions in this formula where we have any leeway to describe what the line looks like, because this y and x value in any function, this is very important, you must listen up carefully now. In any function, the y and the x values just stay y and x when we create the equation, okay? So we only really have this M position and the C position over here to give values to describe, to create an equation that describes a straight line. So this M position over here is the gradient. That value is going to describe to us what the gradient looks like, and this position over here is our y-intercept. That's going to tell us where the line is on the graph. Now that is all the information you need to know what a function is going to look like. M is always the position that's, it's always the value that's multiplied by x. So say somebody tells you 2x plus 3, then you know that 2 is the value for m, right? So then you know m is equal to 2. And you can also tell over here that this over here is your c value. So c is equal to 3, okay? But they can be tricky. They don't usually do this, but they can if they want. They can do this. And now they're going to confuse you because you're like, oh, where's the m and where's the c? The m is the value that, I nearly want to say is married to x there, okay? The m is the value that's right there being multiplied by x, and the c value is over here now. That's the term that stands alone. Okay, does it make sense? I hope so. You need to be able to identify in any given equation, you need to be able to identify which one is which one. I want to quickly talk about what these look like. If m is very high, if m is like say higher than 1, the graph is actually very, very steep. Okay, if it's 1, it usually looks like this, and we'll talk about horizontal lines in another video, but basically like this is a half gradient or whatever, or a third will be, yeah. So the smaller the gradient of the value of the gradient, the shallower it will be, and the bigger the value of the gradient, the steeper it will be. That's not so important. You don't really need to memorize that to spend too much effort. I'm just telling you how it looks. And then our intercept, y-intercept value just tells us where it crosses the y-axis. So if I've got a y-intercept of 5, then I know it's going to cross there. If I've got a y-intercept of -2, I know it's going to cross the line there. So say I give you an equation of y is equal to 2x plus 3. Let's take that as an example here. I'm just going to draw it roughly now. You're probably not going to draw stuff roughly. You're going to measure it off nicely. If I've got a y-intercept of 3, I know it's going to cross the axis, but I now need to figure out my m value is positive, right? It's a positive 2. Now we said earlier a positive line slopes in this direction. So now I know I'm going to have a line sloping in this kind of direction, and it's going to be crossing the axis at 3. And it's going to be pretty steep. It's a 2. So I can probably, if I have to guess how this line is going to look, oh, sorry, that's supposed to go through 3. That was also supposed to go through 3. There we go. So that's probably approximately how that's going to look, but you're not going to do approximate for your teacher. If she asks you to draw, you're going to do it properly, not like me. I want to quickly run through some straight line equations for you. We just eyeball them, okay? So what about y is equal to 3x plus 5? So the gradient is 3, right? M equals 3. So that's going to be pretty steep. Is it going to be a positive or a negative gradient? It's going to be a positive gradient because this is a positive 3, so it's going to slope in the positive direction. And it will cross the y-axis where? At 5. Good. So let's do another one. Y is equal to -2 minus 3. Okay, let's look at the gradient first. Gradient is -2. So that means we're going to have a negative sloping line, and it's going to cross the y-axis at -3. So if I have to sketch a graph quickly, it's going to be -3, and it's going to be a pretty steep line, something like that. Okay, let's do another one. Let's say we've got y is equal to, y is equal to x over 2. I just thought of a really nice example for you guys here. There we go. What about that? Now, this catches everyone all the time. Sometimes I even do a double take when I see it. So, okay, you've got to be very careful about your coefficient here, okay? So your m is the coefficient of your x term, but it's divided by 2. But remember, x over 2 is actually the same. Remember, there's an invisible 1 over here. So this is actually the same as 1x over 2, and that's actually the same as a half x, right? So do you see that x over 2 is actually the same as a half x? So there's your coefficient. It's hiding. So watch out for those, because they do tend to do them sometimes. So your m value is a half, and your c value is, don't write for me 1, please. You need to take the whole term. So I always say that a term is like a number with its clothes on. If the sign is its clothes, you don't move it without its sign, okay? You don't do something, you don't just say it's 1, it's minus 1. It's the whole term. So probably if we were to draw a very rough sketch of this, it would be going through that point. I know, minus 1. And I know the gradient would be pretty shallow, so it might be doing this, something like this. It was a positive slope, I never mentioned that. It was a positive slope, that's why I drew it in that direction. Alright, I want to mention 2 last things about the formula of a straight line, and I want you to pay really close attention. Are you listening? Okay, firstly, you need to know what the different things in the formula stand for. Okay, so if I give you an equation and I ask you what's the gradient or what's the y-intercept, then you need to be able to read that straight off that equation. And if I ask it in a different way and I ask you what's the value of m or what's the value of c, you need to know how to do that. A lot of people actually struggle with this, and that's just because it's fairly simple and it's easy to miss, but it's really important. Secondly, your teacher is going to play with what we call the standard form of the equation. This is kind of higher grade stuff, but it's not difficult if you are expecting it. So standard form is just when y is by itself. It's got a coefficient of 1 and there's nothing being minused or added there. There's no funny business going on there. Y is just all by its lonesome self on the one side, okay? But what your teacher can do is they can bring the y-intercept over to the other side like this, or they can mess with the coefficient, and then usually the grade 9s just have a mini meltdown when they see this in their test. But don't freak out. All you need to do is you just need to imagine you're doing an equation and you're solving for y. So you need to get y by itself again, and then you'll be back in standard form. So it's not that tricky when you know what to do. I know that the things in this video can feel like a lot and it can be a little bit overwhelming at this stage, but that's okay, because as you go, you're going to get more familiar with it and feel more confident. So there's still a lot of function stuff we need to talk about. Thank you so much for watching, and if you like this video, please subscribe to my channel. It'll just help me to make more videos like this one for other people too.